wabarakatuh.
Alaikum salatu wa barakatuh.
I really appreciate this class this morning.
You're welcome.
It's
Alhamdulillah.
very interesting, and in terms of data analysis, it's very amazing, especially for we the young learners
Yeah.
that are coming behind you, sir. My
Welcome.
prof. One of the things that I want to ask is that I can see that we go to a place to pick those data
Yeah.
in order to analyze them.
Yeah.
In a situation where we have a client
Okay.
or we have somebody who said we should help them to run data,
Okay.
how could we be able to get those data we want to use, like those one that has already been prepared that we went ahead to go and pick?
Okay. Okay. Thank you very much. That's a very nice question. Thank you, Mr. Yodeji Yakubu, for that nice question. Yeah. This is the this is the essence of actually having all this kind of free data. They will give you an idea. Actually, if you have a client who give, okay, we have this particular issue to solve, a problem to solve. It could be, people are being absent from my job. How do I deal with it? People are losing a lot of customers. How do I develop a system that we want to know who want to go so that we can talk to them. We can appeal to them not to leave. This is customer churn. A lot of almost all company needs it. So you don't want your customer to leave. So once your client comes to you in any problem they want to solve, the first thing you need to check out is, for sure, they are not the first one to try to do it. In rare cases, you see that it's totally new. So try to see what are the data sets that are available in this area. See, because sometimes in software engineering, we usually say that customers or clients don't really know what they need. See, so you need to help them. So don't expect your client to tell you, okay, this is the data you're going to use to build it for me. No, they don't know how to do it. You are the expert. So you have to guide them. And you yourself, you are hearing this problem maybe for the first time. But for me, I always believe there's nothing impossible. So you need to reach out, okay, first of all, okay, I want to predict this. Oh. Then first of all, quickly, okay, we will look into it, we get back to you. Then you need to go and establish people that have done it in the past. What are the data set they used? Of course, it doesn't mean that's the only data you have to use, but you have to start from a place. So the first thing is to see, okay, what have people used before on this same problem? Let's say, for example, we have data set here. This is the one we use today. Okay, this is related to telecom. See, contract renewal, data plan. What is kind of data plan the person subscribed to? Maybe it's MTN or Airtel or which other telecom company. How much of data is the person using per month or week? See, customer service call. This person, does he ever talk to customer to complain? So we want to see. You see, you can get this data easily from the customer log and the system. So once you identify what are the information you need to get, then you now communicate your client that, oh, excuse me, for us to be able to build this, you need to get data for us, for your customers. You see, so we need this data, the contract renewal. Some of these data, they are available. It's only the client don't know how you are going to use it. And this is one of the advantages of machine learning and data mining. Data is wasting away in almost several facets of life. But we are not making use of those data sets because people don't know we can make use of them. You see, ask any telecom company to provide you with this information about their customer. They will produce you as many as possible. You see, they will produce for you as many as possible. But they never knew we can use it to actually predict if somebody is going to run away or not from our service. So once they have provided this one, then you now try to say, okay, some of them also, they've had customers that ran away. In that case, you can use their own data to label your data. So you now try to label the data, okay, this customer, you provided their data for me. Are they still available? Oh, some of them have gone. Okay, can you identify those that have gone? We label them as the yes. They already shunned the company. What are those other people? They are still available. Okay. Then we use this now to build a model for them. This is their own data. real life data set from this company. We now use to build the data for them, to build a model for them. This model now will be used on other customers subsequently to predict if someone is going to go away or is not going to go away. You see, this is if they have the data set. But sometimes they don't have the data set. They say, okay, all our customers, they are here. We don't have any single customer that left us because we just started. We are a new company. None of our customers ever leave. Okay, in that case, they don't have the negative class. I mean, the one that is showing that they have gone. Okay, what we're going to do is we can try to use unsupervised learning. We try to use unsupervised learning. It's another aspect of machine learning. I described that earlier on, whereby we try to understand, even though we are not going to have training in the classical way, it can study the data and partition them into this customer might leave, this one might not leave, based on the attributes. But that one may not be guaranteed to have the same accuracy like the supervised one. Another way you can deal with it is if customer is not able to provide labeled data, then we go also online and try to get all these free data sets. And then try to use this data set. If there are some company that, like telecom, the same data here, data plan, data usage, is almost universal to every telecom. So you can use this data to train a model that you can use for local telecom company from your own locality that gave you that particular kind of contract or work to do. So this is how you can get the data set. And this is not all. For example, let me show you another example. On the same telecom data, look at this data. This is another data set on telecom Churn. You see it has even the state. It has the account length, the area code, international plan. Do you have any international plan for calling people? Voicemail. Do you have any voicemail message? Number of total day in minutes, total day calls, how many calls in a day? You have other data set that were not in the previous data set that we use. So this is from another telecom company. So that is why, so you have to now go wide, okay, check as many possible data sets online there that will guide you. Then you'll be able to guide your client. You now tell your client, oh, we have a lot of information. Which of this information can you provide for us? So they will select those that are possible for them to provide. And hopefully they will be able to have enough data for you so that you can be able to predict or develop the appropriate model for them. I hope that clarifies and answer your question.
I really appreciate that, sir. It's okay.
Thank
but
you.
My prof,
now
you can see I as an educationist, all my question I normally like to narrow it down to how I can use it to contribute to the educational development of my country and that of the world at large.
Okay.
So I can see that this one is very educative and very informative.
Yeah.
And I would like to private chat you and have some guidelines on some of the research I want to embark on before June.
Okay. That's very good. You are welcome, brother. So you're always welcome. So one something I can suggest for you start thinking is similar to customer Churn, but why don't you start thinking of student withdrawal, student dropout. Want to predict students that might drop out from school. See, it's a very big problem in educational system. Actually, there's a special field we call it EDM, educational data mining. EDM. You can search about that. You can read about that. A lot of work going on there. EDM. I'm writing it here. You can see my screen, eh?
Yes, EDM.
Yeah, we call it EDM, educational data mining. See, we try to mine data from an educational perspective. So we want to see students that might withdraw from the school, that might drop out. So we can know them ahead of time before they drop out. We can try to get across to them. The system predicted that you might likely drop out. What are you facing? A lot of students are facing a lot of challenges that can easily be solved by people, by their advisors, actually, before they actually take the decision to drop away from the school. Also, we want to know students that will fail in an exam. Before you write the exam, you predicted students that might fail. And then it's not because you want them to fail. You now try to talk to them, advising section, so that you can be able to identify why is it likely going to fail, to prevent the failure. See, this is what I call positive use of machine learning. We predict that a problem might occur, not because we want the problem, but we wanted to know ahead and prevent that problem from happening. We can use it. So just like in other field, like for example, accident prevention system, we predict there might be accident in some spots to prevent it from happening by deploying police at that particular junction before the problem happens. A lot of these are practically real life problems we can solve actually. So in educational sector, apart from the dropout, we want to be able to know students that might, what is going to be the final grade the student we're going to graduate with. So, like I said, try to read about EDM, educational data mining. You will see a lot of resources and idea in that respect. Notwithstanding also, feel free to private chat me, so on further guide and any question clarification. So I wish you all the best. Barakallahu fiik.
Amin.
You are welcome, brother. So I think that's where we have Muhammad Balogun.
Assalamu alaikum.
Alaikum salam, brother.
Thank you very much, Prof. My question is that most of the data set we are using from this Kaggle is like they have been prepared before. It's like they have been cleaned.
Yeah.
Mm-hmm. So my question is that because they say that because most of the data that we usually have, according to what I used to have here, is that the reward data, the data scientists spend most of their time in data preparation, cleaning the data. So from the concept of that you usually discuss that let the data speak. So once we get the data, should just try to use it to make predictions first, or should we start checking whether the data contain error or something like that, or we should just make the precision first before we start cleaning the data or preparing the data for prediction. Because what I heard is that making a prediction with a data that is not clean can actually lead to false prediction.
Okay, thank you very much. Yeah, thank you very much for that question. You see, the data pre-processing or data cleaning is a relative term. You get the point. It can be as many as possible and can be as small as nothing. You mean if a data comes in, you're so lucky you have a very nice data from your client, nothing is missing, everything is fine, you are good to go. You see, you are good to go. But I've seen a student who had I kind of understand that there must be data cleaning. So he got data set, he started trying to, this data set, there's no missing value, there is no outlier. Then he started to say, I think the values are many, let me normalize it. I think, it started normal. It's just believe that you must do something. Yeah, these things are there. But it's always good to, first of all, let the data speak. You see, what we just did today is just a kind of a little guide. If we are not saying the project is done, it's completed. You can see we didn't demonstrate hyperparameter tuning and the like. So, but first of all, let the data speak. Except you run your data. There's some data say you run it, it's not going to run. It will generate error. It means something is totally wrong. Or you check your data set, you look at it, this data will not work no matter what I do. Then, in that case, there's nothing you can do. You have to first of all work on your data set before you can do anything. However, if data test is complete, no missing value, even in some missing value scenario, you still have some algorithm that can still even work for you. Then that is why you have this thing I'm showing here. See, it's a kind of a iterative process. You don't lose anything by running your model and then coming back to see that, I need to work on my data set. For example, I've seen students, they just got the data set. Right away, they say, this data is imbalanced. So they started balancing the data immediately. No. Let's see how the data will perform, even with the imbalancing. It's actually that imbalance you are resolving is supposed to be part of your contribution. You see, let's see what the original data we produce. It's working. Imbalance data, you can see that some algorithms were able to classify it correctly. I've worked on some of a student team, they work on an imbalanced data, really highly imbalanced, but still they got 99% accuracy without even doing the balance. You see, sometimes it happens. And that's okay. Now go back now, try to balance it and see what you get. Then we now start the comparison system. So what we're saying is you don't need to spend the whole time working on the data. Clean data is relative time. Once your data is at acceptable level, you can go in for modeling. Then you see the way it goes. To me, this is really letting the data speak, the raw data, before you start manipulating the data. You see? And also, it's going to be part of additional work or contribution you are trying to make. Okay, I run the data set. True. I notice, okay, we noticed that, okay, could it scale up to what we were expecting? What could be wrong? Okay, let's do the outlier detection. Let's do, okay, there's no missing value. Outlier is not there. Okay, let us normalize the data. So there's always room for you here to go back and forth. So I've seen people want to stay here as long as possible. At the end of the day, they miss important steps they're supposed to do. So because cleaning is relative, what cleaning is enough is also a relative term. But clean it reasonably, go into modeling. The output will tell you what next we need to do. Improvement is still needed, as the case may be. If your data is not good, you are not going to get good result, for sure. You are not going to get good result. So if good result is coming, it means those cleaning processes you didn't do, they are not really important, or they are not compulsory at that point in time. So I hope I clarify your points to some level. Thank you.
Thank you, sir. Okay.
Mr. Umar, I think the last questioner before we call it a day, please.
Okay, Assalamu alaikum.
Walaikum salam wa rahmatullahi wa barakatuh.
Jazakallah, Prof. Thank you very much for these classes. I started last week and I've really been following your videos on YouTube. Thank you so much, sir.
You're welcome. Barakallah.
Okay, thank you, sir. My question is directed towards, I'm trying to venture into computer vision.
Okay.
Yes, sir. So I tried to use this Fashion MNES dataset that is very popular.
Okay.
But using the normal Python programming. So I wanted to use it on WEKA, but it was taking so much time. So I was not thinking maybe it was because of I could not flatten the I could not flatten one of the layers to convert the picture into one dimensional array from two-dimensional array to one-dimensional array. So I don't know if it can be done on WEKA. And if computer vision also is very good with WEKA. Sorry, sir.
Okay. Well, yeah, depend on the power of your machine. That is one thing. So it depends on the power of the machine. It also depends on the knowledge of programming. So if you know how to program it with Python, you can compare them together. It depends on the data set also you want to use. Okay. But like I always said, machine learning is independent of platform. With a very powerful machine, I want to believe you should not have a problem running your vision related projects on WEKA or any other machine learning platform. So we have to look at your memory utilization. So how much of your memory has been utilized? Is it taking so much time? How long time is it taking? So we have to look into that one. But for sure, Python has that capability to deliver on deep learning, as the case may be, or any other platform. And then you can also try other platforms like Orange. Orange is also another GUI base. If you are not good in programming, you can also try Orange. Orange is also, it allows you to just click and select your data and start running. So depending on the kind of data you are using, the power of your machine, all this will contribute to the possibility. But if you still face any issue for that, then you can actually also private chat mean that then we can see other suggestions we can make for you. Inshallah.
Okay, thank you so much, Prof. I really appreciate it. Thank you, sir.
Barakallah. And when you run such performance intensive system, try to avoid loading so many things on your machine, even up to your browser. You see, when you open several browsers at the same time, this can also, especially if you are using laptop, but for vision imaging oriented, it's always good if you use desktop. But this is the challenging part of processing videos and imaging. They take a lot of spaces. Yeah.
Okay, that's true. Because actually, I was running so many programs at the same time. I think I'll try that, sir. Thank you so much.
So try to reduce that because video and imaging will take a lot of spaces on their own. So on either at the runtime or that one. Barakallahu Fiik, wish you all the best and you're welcome to the class. So,
thank you, sir.
Once again, so thank you very much all for coming. So wish you all the best in your various endeavors. So this is how we're going to have it for the day. As we always say, you're always free to share with your friend, invite your friends. Essence is so that as many people as possible can benefit. So thank you all, and I wish you all the best. Assalamu alaikum.